Hello, my name is Rob Janik. I'm the Director of New Technology at Jacobs Vehicle Systems. We're here at the Thompson Speedway to do our cylinder deactivation and active decompression testing and demonstration. This is technology that we created, cylinder deactivation primarily, for improving the thermal management of the engine. Thermal management allows us to lower NOx, lower the criteria pollutants coming out of the after-treatment system. But we can do that also with improving the fuel consumption. We actually lower CO2.
Steve Carlson from Tula Technology. We're a software company that provides whole software implementation for cylinder deactivation. We're here today to demonstrate dynamic skip fire and cylinder deactivation with Jacobs.
On the display here, you can see the torque that we're running. We don't really run the CDA until we're down under 500 Newton meters. But you can see when we're decelerating, we have 0 cylinders active.
Cylinder deactivation is not a technology that's really deployed too much on the high load conditions, so it's not a performance improvement on that side. This is all about when the engine power isn't needed. So fleet runs that are using diminishing loads, returned home to base empty, and the idle conditions is when cylinder deactivation is used.
When you get to that low load, it's still pumping 6 cylinders worth of air through the after treatment system. And with the deactivation, you can shut down the other cylinders that aren't needed and supply the power needed with maybe 2, 3, or 4 cylinders.
Again, as we coast, we go to 0 cylinders, and you can see the temperature very slowly decreases. Whereas in 6-cylinder operation, you're pumping a large volume of cold air through the after treatment. So the goal of CDA is to try to prevent that cool off that occurs, so that the heat generated during the high load operation can be maintained and you can keep that SCR system in an efficient temperature. The other benefit from the 0-cylinder mode, you might notice the truck doesn't really slow down much. So we have a much lower motoring friction on the engine, and with that you'll see a real world benefit. It's like reduced rolling resistance. So you'll see a real world benefit from that's not shown on an engine dyno test.
The testing that we've shown and we published in the past 4 years so far is we showed in a low load cycle, that's one of the certification cycles that are in the market now, we can show up to 12% fuel consumption savings while still reducing NOx to, I think it was over 80%. And even in an FTP cycle, we show between 3 and 5% fuel savings at the same time of reducing NOx.
And some of the benefits that we're finding with this is really to focused on the 2027 emission regulation reduction, which is the NOx reduction largely.
But at the same time, there's already existing rules that are on greenhouse gas, which are all about reducing CO2, improving fuel consumption. So those both have to happen at the same time, just on different schedules. So technologies that can do both fuel consumption saving and can raise temperatures or improve the after treatment system is what's needed. The second technology is active decompression. That allows us to decompress the engine. That gets rid of that shake as the engine shuts down, and also improves the startability of it. So we're hoping that's going to improve the acceptance of stop-start, because we reduce the wear out of that start and stop of the engine, so we can get rid of idling whenever it's not needed.
My name's Bob LeBlanc. I'm the warranty manager in North America for Jacobs, and I'm also the test development truck driver. Today we're going to demonstrate our ADT. Currently we have it deactivated. This is going to be the standard engine shutdown that we're going to demonstrate. And you can hear the rattle and the shake and the roll of the chassis. And then on standard startup, you're going to hear the standard engine starting up under compression and so on. Here we're just going to activate it. This is now with the system activated, and you're going to feel a very smooth wind down of the engine, and there will be no shake of the cab. And then on startup, you're going to hear a small whine, and you're starting the engine with no compression, and therefore there's a less load on the starter, less load on the batteries, and so on.
So it's the sleeper cab. So when the truck has to auto start in the middle of the night to recharge the hotel batteries, when it shuts down, it gets that death rattle, that shake gets quite extreme. It can actually wake up a truck driver. So that was how that system was originally developed, was to actually get rid of that shake. It was through the development of it and the testing that we proved out that we can actually improve the startability and the cold start, all those extra benefits that allowed us to maybe promote this as a stop-start system.